Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be modeling percents. Let's start with the definition. A percent is a special ratio of a part to a whole, where the whole is always 100. For example, 62% is equal to 62 100ths, which is also equal to 0.62. Example 1. On a recent test in English, Jameson scored 17 out of 20 points. His friend, Avery, has a different English teacher and scored 20 out of 25 on a similar test. Why is it difficult to say who scored better on the test? Think about that for a moment. All right, hopefully you said it's difficult to say who scored better because each test had a different number of questions. Part B. Give a fraction for both Jameson and Avery that represent the ratio of the questions they got correct to the total number of questions. Do not simplify. So Jameson, he got 17 out of 20 questions right. Avery got 20 out of 25 questions correct. All right. In problem C, rewrite each fraction in part B as an equivalent fraction whose denominator is 100. So let's start with Jameson here. I want to rewrite the fraction 17/20 as a fraction with a denominator of 100. So we can scale up 20, we can scale it to 100 if we multiply by 5. But if we multiply the denominator by 5, we're going to have to also multiply the numerator by 5. So 17 times 5 gives me 85. Now Avery got 20 out of 25. We can rewrite that fraction with the denominator out of 100, but this time we would have to scale by 4 because 25 times 4 is 100. So if I scale the bottom by 4, I'm going to scale the top by 4. So that would give me 80 out of 100. All right. Part D, based on your fractions from part C, who did better on the English test? So now that both fractions for Jameson and Avery have the same denominator, it's easier to compare them, and we can see that Jameson got 85 out of 100 and Avery got 80 out of 100. So we can say that Jameson scored better on the test. Again, when we want to compare fractions, we need to have the same denominator. So here, having the same denominator of 100 allowed us to see who scored better. Example 2. The rectangular models below are made up of squares. Determine the percentage of each model which is shaded. So remember, a percentage is a part to whole relationship. So if we want to determine the percentage of each model was shaded, we need to determine the number shaded. So number shaded divided by the total number. So in this problem, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is a 10 by 10. So we know there's a total of 100 squares. And let's see how many are shaded. So this would be 10, 20, 30, 40, 50, 60. 1, 2, 3, 4. So 64 out of 100 are shaded. So 64 out of 100 is 64% of the squares are shaded. All right. Try problem B on your own. Pause the video. Then when you're done, press play to check your answer. All right, welcome back. Let's see how you did. 1, 2, 3, 4, 5, 6. So in this problem, 6 out of 100 squares were shaded. So that would be 6%. All right. Let's talk about converting between percents and decimals. To convert a percent to a decimal, you divide the percent by 100, which is the same thing as moving the decimal 2 places to the left. To convert a decimal to the percent, you multiply the decimal by 100, which is the same thing as moving the decimal 2 places to the right. Let's try this. Example 3. Use your understanding of converting between percents and decimals to convert each percent to a decimal. So if I want to convert 72% to a decimal, I'm going to divide it by 100, which means I simply divide or move my decimal 2 places to the left. So this would be 0.72. So 32%, move my decimal 2 places, would be 0.32. Now be careful on the next problem. We have 6.5%. If I move that decimal 2 places to the left, I'm going to need a placeholder. So this would be 0.065. Pause the video and try problem D on your own. When you're done, press play to check your answer. All right, in problem D, hopefully you got 0.05. So 5% written as a decimal, 0.05. All right, example 4. Use your understanding of converting between decimals and percents to convert each decimal to a percent. Now this time we'll be multiplying each decimal by 100, which means we'll move our decimal 2 places to the right. So 0.25 would become 25%. 0.62, 2 places to the right, would become 62%. 0.09, move your decimal 2 places to the right to get 9%. And on problem D, if I move my decimal 2 places to the right, 1, 2, I'm going to need a placeholder, 150%. Example 5. The rectangular models below are made up of squares. Determine the percent of the rectangle that is shaded and then express that percent as a decimal. So, first of all, remember we're going to get the ratio of shaded squares to total. So let's see how many total we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. So this time our total is 80. Now, how many are shaded? Well, we have 8 times 4. That's 32, 33, 34, 35, 36. So 36 out of 80. Now, I want to rewrite this as a denominator of 100. So the first thing I'm going to do is reduce this. I'm noticing they both divide by 4. Let me write that down so you'll know how we got this. If I divide them both by 4, that would be 36 divided by 4 is 9. 80 divided by 4 is 20. Now I want to rewrite 9/20ths as a ratio with a denominator of 100, kind of like we did at the very beginning of the lesson. So to scale 20 to 100, I would have to multiply by 5. If I multiply the denominator by 5, I must also multiply the numerator by 5, which that would be 45 over 100. All right, now that we have a denominator of 100, now we can easily tell that the percentage is 45% and the decimal is 0.45. But remember, you cannot get the percentage until you have a denominator of 100. That is very important. So if you are not given a denominator of 100, then you're going to have to convert it to 100. All right, let's try another one of these. All right, we have how many total squares? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. So our total number of squares here is 40. And how many are shaded? 5, 10, 15, 20. 1, 2, 3, 4. So 24 out of 40 are shaded. Now again, 40 will not go into 100 evenly. So let's try to reduce this. Let's take half of each of these numbers. That would give us 12 out of 20. Now look at it again. Will this denominator scale to 100? Yes. So let's do that. Because remember, we cannot determine the percent until we can write our fraction with an equivalent fraction that has a denominator of 100. So I can scale this to 100 if I multiply by 5. So 12 times 5 gives me 60. So now that we have a fraction with a denominator of 100, now we can determine the percentage. So this would be 60%, and as a decimal, 0.60. And that concludes today's lesson, modeling percents.